Alright, here we go. A little technical difficulty. So here are two restrictions. Let's talk about, is it a polynomial function, yes or no? Okay, so here's our first example. Y equals 5x cubed. I'm making it as easy as I can. Is that a polynomial function? Yes or no?
Yes.
Yes, it is. Alright. How about now? No.
Yes, it is.
Is pi a real number? The coefficient is a real number. That's good to go. This is a polynomial function. Yes. We're okay. Okay? Do another example. And you don't have to write all these down. You can watch, or you can try to write them all down. That's fine. Is this a polynomial function now?
Yes.
Alright. How about now?
Yes.
No.
No.
Why not?
Because we got a negative. It's not a whole number.
Because the exponent is no longer a whole number, then it is no longer a polynomial function. Nod your head if that makes sense. Okay? How about now?
No. Yes.
Is 1/2 a real number?
Yeah.
So we're still okay. How about now?
Yeah.
No.
No, why not?
That's the number.
Yes.
Because 1/3 is not a whole number.
Oh,
Alright.
that's what we got to do.
No.
Yes, because it's 1.
No.
It's not negative or imaginary, it's 1.
It's not imaginary, right? The coefficient is a real number. It's still a polynomial function. How about now?
No.
Why?
It's a negative.
Because that's imaginary. You can't take the square root of a negative number. This is imaginary, which means it's not real, which means it's not a polynomial function. Okay, questions? I think you got that. Once we do a few examples, I think it'll cement it even more.
I'm going to feel this.
All right. The next thing that we need to talk about is the degree and the leading coefficient. Read the definition for degree, Jacob, for me. Right there out of the book on page 66.
The degree of a polynomial function is the exponent in the term where the variable increases the greatest power.
All right. So here's a polynomial function. We're back to this example. This is the degree. Why? Not because it's first, but because it's the largest value. Okay? This is the degree. Write that down. The degree is 4 in this example because it is the highest value exponent. The second definition there, Jacob, if you'll read for me, is leading coefficient.
The leading coefficient is the coefficient in the term of a polynomial function that has the greatest exponent.
So if this is the degree, then the coefficient that is tied to that one is the leading coefficient. You can just say LC and I'll know what you mean. In this example, this is the leading coefficient and this is the degree. They go hand in hand. You can't have one without the other. Here's another example though. What is the degree in this example?
4.
You might be tempted to say 1 or 2 and get confused. But if I've got a 1, a 4, and a 2, 4 obviously is the biggest. The degree is 4. What is the leading coefficient? 7. The 7 and the 4, they go together. Okay, that's not a hard concept. But we have to talk about it so that later on when I talk about the degree or the leading coefficient, the degree, is how many turns the graph has. The leading coefficient tells what the graph is doing, the end behavior. Right? If a polynomial, if A is positive, the polynomial opens up. The parabola. Sorry. If the parabola opens down, then A is negative. That's the leading coefficient right there. So if this value is positive, that tells you one thing. If that value is negative, it tells you something else. The degree tells you whether it's a quadratic or a cubic or a quartic. The degree is very important as well. Question?
I was going to ask what if the degree is the same for each one?
If it was the same, good question, right? If I had y equals 5x squared plus 7x squared, then those are the same and they would need to be combined to 12x squared. Okay, great question. This we would say is not in standard form yet. And that leads me to my next thing, is to talk about standard form. Very good. A polynomial function is in standard form if the terms are written in descending order of exponents from left to right. Descending order. Does everybody see the exponents? Right? X to the fourth, x cubed, x squared, x to the first, and then I say no x, but that's actually x to the 0. So write standard form on your paper right there. Your exponents, as you read it from left to right, are in descending order. And then we call it standard form so that everybody is talking about the same thing. We cannot do synthetic substitution without it being in standard form. It has to be in standard form first. If 5 people give me the answer and it's all in standard form, then everybody's going to have the same answer. Okay, that's why we say it's standard. Questions? That was a good one. Anybody else have a question? All right, turn in your workbook. Let's stop here and let's practice a few problems before we move on. Workbook, page 79. Workbook.